Hello again. So, last time we discussed a few programs and one of the objectives of the course. So, this lecture I will consider some more information about do statements, if statements and finally declaration statements. Remember last time we said declaration statements also constitute one of the ingredients of the program. So, a declaration statement really determines what variables are going to do in the program. So, coming back to the do statement, remember that we had statement like do 10, I going from 1, 100, 1. So, earlier we did not have this last comma 1 because it was understood that in this do statement, I will start with a value 1, next time it will be 2, next time it will be 3 and so incrementing by 1 was understood. So, this is a default value. The default value is that which it considers without our specifying anything. But suppose I want to increment something not by 1, but by 2, that is I want to consider all odd numbers between 1 and 100. How would I do that? 1, 3, 5, 7 and so on. So, to do that, instead of incrementing the do loop variable I by 1 every time, I will increment it by 2 every time. So, how will I write that statement? Look at this now. Do 10, I going from 1, 100, 2. So, every time the loop comes back. So, what is this 10? 10 is again a line number. A do statement executes everything from the starting do statement up to the last statement which is line number 10 and it will do it until the value of I is matching this or becomes greater than this. So, in this case first time it is I equal to 1, execute all the statements, come back, second time it is not 2 but 3 because it is incrementing I by 2. So, second time it is 3, execute everything up to line number 10, come back, now I becomes 5 the third time, all the way, then go back, you will go on repeating 5, 7, 9 all the way. I will become 99, go back, do everything, when it comes back. So, when it is already 99, next time it will be 101. So, it will not execute 101 because this statement says nothing more than 100 is permitted. So, what this new type of do loop will do, it will execute all those statements for only odd numbers. Now, my next question is what will you do if you want to do all even numbers? Suppose you want 2, 4, 6, 8. Give a thought to that. The way to do would be do 10, I going from 2, 100, 2. So, instead of starting with 1, I start with 2. So, when I start with 2, first time I do the calculation for 2, next time that 2 is incremented by 2. So, I will get 4. So, in this way by changing the initial value of I am able to get even numbers instead of odd numbers. So, one more point, in many of the programs we have studied so far, I am always saying do 10, 10 continue. What is this 10? 10 is not some object worth 10, 10 is just a line number. Instead of do 100 I going from 1 to 2, I could have said do 103 I going from 1 to 2. So, since this is 103, then this line number will be 103. Instead of 103, I can say do 999 I going from 1, 100, 2, 999 continue. After all, this is a line number and in programs there is no requirement that all line numbers should be in an ascending order. The first line label could be 10, the next line label could be 3, the third line could be 22. So, these line numbers are just for our reference, but computer does not bother, we can give whatever line number we want. But still it is a good practice that you keep all the line numbers increasing, so that you know that once you come to a line number 100, maybe you are somewhere in the middle of the program. So, it is a good idea to call the last line as 9999, it is just a suggestion. So, whenever you come to this such a large number, you may think that it is the end of the program. Okay. Now, we have considered do statements with a line number. There is another way to do this without line numbers, because line numbers are good in many ways and sometimes they are not good as well. So, there is a way to do this set of operations without using line numbers. So, what is the way? Let us look at the next program. This program is really, it calculates the sum of some numbers, it calculates the sum of the cubes of real numbers between 1 and 100 incremented by 2. So, look at this line, sum is equal to 0, do I equal to 1 comma 100 comma 2. There is no line number. So, it is a do statement. The next line is sum is equal to sum plus real I raised to third power. So, first time I is equal to 1, third power of 1. Next time this I has become 3. So, sum is 1 cubed plus 3 to the third power. Next time I is 5. So, the sum would be sum plus 3 cubed plus 5 cubed. So, each time increment I by 2, take the cube and add to the value of sum. The sum keeps on incrementing. So, instead of this 10 continue, now I am saying end do. Do something for a given sequence of numbers and end that do. So, finally, when I is equal to 99, next time I will be 101. So, it knows that I will exceed the upper limit. So, the entire do loop will end. The do loop will end when the variable I is greater than the second value in my loop statement. So, as we have seen already now, there are many ways of writing your do statements. So, in something like a C program, they do not have a do, they have what is called a for loop. So, whatever is a do loop in Fortran is a for loop in C. So, different programming languages will have different labels for these operations, but the spirit is the same. What is the spirit? You want to have a repeated set of operations, start that operation with a given number, keep on doing, increment that number by something, keep on doing. When that number exceeds an upper limit, you end that do loop. Okay? And the other point, computers treats real numbers and integers very differently. Integers require a lot of space, real numbers do not require the same amount of space, because in a real number I can represent the decimal part by 8 digits and the exponent part I can keep it separately. Suppose I have 0.1, if the exponent is 5, that is 0.1 raised to 10 to the 5. Okay? So, whereas integers are different, they need a lot more space. So, integers are treated very differently. So, I have discussed this do loop now. Next what I will discuss is how to branch in a program. Branching is a very crucial thing. Okay? So, we want to show the branching by plotting this function or by seeing the plot of this function. What is this function? This function has certain values. For all negative values of x, the function value is 0. Between 0 and 5, the function has a value of 5. Between 5 and 10, the function has a value of 10. Beyond 10, so 10 to 15, the function takes the same as the value of x. So, if x is 13, function will be 13. If x is 15, function is 15, and beyond 15 I have not defined anything. So, this function is defined from minus 10 up to 15. So, minus 10 to 15 are all the values that the variable x takes, and the value of the function goes from 0 up to 15. So, the range is 0 to 15 and the x takes the values from minus 10 to plus 15. So, how will I evaluate this function in a program? The program will read the value of x, and if the value of x is, let us say, minus 5, I know from the graph that the function of x will be 0. So, now if the value of the function, if the value of x is say 3, the function has a value of 5. If the value of x is say 7, the function value is 10, and beyond 10 to 15 it is a linear function, that is whatever is the value of x, so is the value of fx. So, my program should do that. So, what will the program do? It will read the value of x, and depending on what is the value of x, it will give you the value of fx. So, naturally now there will be many conditions in the program. The moment I read x, I ask the question whether x is between 0 and 5, whether x is between 5 and 10. So, I have to have many if statements to find out what the value of the function is. So, this entire thing is illustration of the use of the if statement. So, let us say now this is my program. So, what is this now? Program, we are writing a program which gives the value of function x as per the above formula. So, now that is what we are giving here. So, since the program starts, again this read should start in the 7th column. It should not start in the 1st to 6th column, because then it will give an error. All Fortran statements will start from the 7th column. So, what is this program doing? Read star comma star x. So, what is this star comma star? That means it reads from the screen. From the screen, the computer value will read x. Then you are asking the question, if x is less than 0. So, this is actually what it means. This is a condition now. The condition starts with this left bracket x dot lt dot 0.0 bracket complete. That means, if x is less than 0.0, then function is equal to 0. That is exactly what the graph said. If x is less than 0, then function is 0. The next statement, else if, now see, if x is less than 0, then function is 0, then there is nothing like else if. All else ifs will be void, then it will go write x and function. This is in quotation mark. What is the meaning of quotation mark? This x and function x, function equal to is written on the screen. Again, write star comma star means it will write on the screen. It will on the screen it will write x comma function equal to quotation x and function. So, if x was let us say -5, this function will be 0. So, it will if x is less than 0, only these two will be evaluated and you go back and complete. Now, suppose x is greater than 0, then this else if comes into play. Else if, okay, what is the statement? 0 less than equal to x and x less than equal to 5. So, now this statement, it is a little more complicated than this. The first one had only one comparison, x less than 0. This less than 0 is called a relational operation. What this LT does, it compares whether the left side is less than the right side. If true, then it will go forward. If not, then it will skip and go to the next line. So, now this if statement is a combination of two statements. What are those two statements? 0 less than equal to x and x less than equal to 5, less than 5. See, there is also a difference. Less than equal to means it could be less, it could be equal to. Less than means it is actually less than. This is an inequality. This is an inequality where the upper range can be equal. So, when you come to this else if, certainly x is not less than 0. Since x is not less than 0, it will be greater than 0. If it is greater than 0, it could be between 0 and 5, or it could be greater than 5. So, what this is doing, if x is greater than 0 and x is less than 5, then the function takes the value 5. Remember, go back to this. What was this function? When x is between 0 and 5, it took the value 5. When x is between 5 and 10, it took the value of 10. Okay? So, I am executing this part of the program. X is greater than 0 and x is less than 5, then x will be equal to 5. So, this is the else if part, the second part of that statement. The third else if will be between 5 and 10. The fourth will be beyond 10. Okay? So, now going back. So, if x is between 0 and 5, it will give a value 5. Now, suppose this is satisfied. Once this is satisfied, it goes to the end and writes the value of the function. If it is not satisfied at this level, then again it goes to the next line. Else if 5 less than equal to x and x less than 10. Again there are two statements, and is a combination. And means the left has to be satisfied and the right has to be satisfied. So, again it is dot a and d dot. This is an operation. Dot lt dot is an operation. Dot le dot is an operation. There are three operations here. The first operation says that 5 is less than equal to x. That means x is equal to or greater than 5. X is greater than 5 and the second one says x less than 10. So, x is greater than equal to 5 and less than 10. So, it is in the third range, then the value of the function is 10.0. So, once these three if this condition is satisfied, again it will go to end if and write the value of the function. Now, suppose x is greater than 10. If x is greater than 10, first condition is not satisfied, second is not satisfied, third is not satisfied, then I will go. So, when I come to else, all the three conditions are not satisfied because x is greater than 10. When x is greater than 10, we said function is equal to exactly x. It was a linear thing between x equal to 10 and x equal to 15. So, if x is 12, it will write the value of 12 and 12. So, once all these if and else if are satisfied, then I am saying end if. So, end if says the work of that if function is completed. Okay? The if function is completed when all those 4 are tested and it comes out. So, now there are two problems with this program. One problem is what if x is minus 40, because I never told in my graph, if you see in my graph the value of x was between minus 10 and plus 15, okay? Whereas in the program there is nothing for it to recognize if x is say minus 40. Now, suppose x was minus 40, what will it do? Certainly x is less than 0 if it is minus 40, then it will make function equal to 0 and end it, right, and end. So, if x is less than 0, it will give the value 0 for all values of x which are less than 0. Similarly, all values of x which are greater than 15, the function will be 15. So, this program actually calculates the function where this horizontal line is extended to all values of negative and this straight line is extended to all positive values beyond x equal to 10. So, we wrote the program, it does quite all right for the range that we are considering, but it also gives values for values of x which are outside the range, because I did not give any condition. So, now I will leave as an exercise. Suppose x is minus 40, then your program should say that function is not defined at minus 40, because my graph did not have any values for x less than minus 10. So, these additional lines you can add to make sure that x takes on only those values where you have defined on your particular graph. So, the next task we want to do is, now we will go to a slightly more complex problem. Now, we want to solve a quadratic equation. So, you will say that look, this is something not very complicated, I have already solved it, but we want to solve a quadratic equation for all values of a, b and c. The quadratic, so general formula is ax square plus bx plus c. Now, if you write a program to solve, there are two roots of this equation. Once you write a program to solve this, you do not have to do any further calculations, you just input the values of a, b and c. What you will get is the result of this calculation, which are the roots of the quadratic equation. So, what are the formula for the roots? You know very well that the formula are minus b plus b square minus 4ac minus b plus square root of b square minus 4ac divided by 2a. That is the first root. Second root is minus b minus square root of b square minus 4ac divided by 2a. So, these are the two roots. Now, you will see that when I say square root, so this is b square minus 480 minus 4ac start r to the minus half. There is again a problem here, this should not be minus because I just want to take the square root. If I do minus, the whole thing will go in the denominator. Okay? So, therefore, this minus should not be minus. So, it is minus b plus or minus b square minus 4ac divided by 2a. Remember this bracket, the square bracket is here, the starting square bracket is here, all those things in this are part of the square brackets, this 2a is in the denominator. The other thing you will notice, I have called it 2 star A, both are put in brackets. Now what will happen if these brackets are not there? If the brackets are not there, it will calculate this numerator, it will divide by 2 and it does not know that A is in the denominator. It will multiply the numerator by A. So in a computer you have to be very careful. It goes from left to right. So unless you put the brackets, it will think that A is not in the denominator. So make sure that you are dividing by 2A, I am putting this bracket. So this is my formula for the quadratic solutions. So now let us see how to write the program. So let us begin that program. First line is a comment card, program quadratic. Okay. So this is okay. This is the starting line. It just gives you information that you are trying to solve a quadratic equation. Then on the screen you will write this. Going back, we did mention about compilation and execution. How will you compile? Suppose the file name is prog.f. If you recollect, the compilation is f77 prog.f or gfortran prog.f. This will give you an executable file a.out. The way you execute it, ./a.out. Tomorrow we will actually evaluate this. So once the program starts, you want to see on the screen input the values of A, B and C. So the first line, what it is doing, star comma star means right on the screen, whatever is written between these quotation marks, this is written on the screen. It says input the values of A, B and C. So once you write this, you will see on the screen input the values of A, B and C. So the third line of the program, it says read star comma star A, B, C. This really is the input to your program. Why do I say this is the input? Because your program calculations will start only when you give values of A, B and C. So once you read A, B and C, so what I am doing here now, I am checking whether A is equal to 0. Okay. So if A is equal to 0, go back to this. If A is equal to 0, okay, the first term is not there at all. So it is just Bx equal to C, and if B is not equal to 0, the solution is x is equal to minus C by B. So when I solve this, remember in this particular line I am dividing by 2A, and in a computer you cannot divide by 0. If you divide by 0, it will be a big error, computer does not know what to do. Therefore, you have to make sure A is not 0, and that is why you have that statement A is not 0, and if A is 0, solution is x is equal to minus C by B if B is not 0. That is my first statement. If A is not equal to 0, then you can proceed to the next two lines. So this if statement, again it is a joint if statement. It does two things. If A is 0, so that means it is not a quadratic equation. Okay. So the first part A dot eq 0.0, if A is equal to 0 and B is not equal to 0. Okay. If both these are satisfied, it is not a quadratic equation, then it is only a linear equation with a solution x is equal to minus C by B. Okay. Then 2A is 2A. Okay. Write the solution of a linear equation is x, correct. So if A is equal to 0, okay, it calculates 2A, it writes the solution of a linear equation is x and go to 100. Okay. So there is a slight problem in this statement. We will see tomorrow when we actually execute it. Now I have considered the situation where A is equal to 0. Now next I come to that statement. If A is equal to 0, it will do all these things. It is okay. I thought that there could be some error here. There is no problem. If A is equal to 0 and B not equal to 0, it will do all these statements up to this one. Go to 100. So if A is equal to 0, it will come up to this point and go to 100. It will come here and end if. So the last line should be 100 and some statement with respect to that. So now the next part is if A is not equal to 0. Okay, no. So let us see. Here A is equal to 0 and B is equal to 0. Both are equal to 0. Then what happens when both are equal to 0? There is nothing to solve because go back. You will see that if A is 0 and B is 0, there is nothing to solve because then C has to be 0, because quadratic equation is ax square plus bx plus c equal to 0. So, if A and B equal to 0, there is no solution. Okay. So, go to 100. So, all these lines will consider A equal to 0 and A and B equal to 0. So, that if ends here. Okay. So, if either A and B was 0, it will go to the line 100, which is really the end of the program. So, you see this is continuing from the last screen. So, 100 continue end. So, the earlier things are executed if A is equal to 0. Now, if A is not equal to 0, then I come to this next line. So, when I come here, now WW is your B square minus 4AC. So, I know that when I come to this WW B square minus 4AC, A is not 0. So, this is what is the discriminant, they call it whatever is in the bracket. So, now it is possible that this WW is equal to 0. If WW equal to 0, go to 50. So, go to 50, then you will continue this, and if WW is not 0, then you do this. Okay. So, if WW is less than 0, okay, then go to 50. So, 50 it will do all these things. So, what this is doing is that if WW is negative, you cannot take the square root of a negative number. Since you cannot take the square root of a negative number because they are imaginary, you will have a real part and an imaginary part. So, this part we will consider in the next class. Today what we will consider is that WW is not less than 0, then I have two real roots. Two real roots, I will take root of WW, RTO FWW, this is just a variable. I have the habit of giving variable names which tell you what it is doing, root of WW, because I have WW is a number, it is positive. So, now I consider root of WW is the square root of WW, because I need it to solve the quadratic equation. So, first root would be minus B plus square root of B square minus 4AC. After all, what is WW? WW B square minus 4AC. So, I calculate B square minus 4AC minus B divided by 2A. This is my first root. Now, what is the second root? Minus B minus root of WW divided by 2A. This is the second root. So, then what do I do? Write star comma star, okay. Real roots 1 and 2 are, so this will write on the screen, real roots 1 and 2 are root 1 and root 2. Then go to 100. When you go to 100, that is the end of the program. See the last line? Although I told you that you need not label lines in a sequence, giving large numbers to the end is a useful thing. So, let me summarize what we have done. We started with a quadratic equation ax square plus bx plus c. We consider the case where A is 0, in which case it is a linear equation, and the second case we consider is when b square minus 4ac is positive, because if b square minus 4ac is positive, I will have real roots. I have printed the real roots here. If b square minus 4ac is less than 0, I will have imaginary roots. So, that I shall consider in the next class. So, to summarize what we have done, we considered different parts of the program, especially those which involve iterations. So, different types of do statements we consider, do 10 I going from 1 to 100 or do I going from 1 to 100. We also considered how to increment by 2 units your do loop variable. Then we considered the elementary quadratic equation, how to solve it. So far we have considered to solve it for only real roots. For imaginary roots, we have to change a little bit. That I will start in the next class. Okay? Thank you. Revise all these things, and from next class onwards, we will start actually doing the computer work. We will actually calculate all these things on the computer so that you can participate in the process. Okay. Thank you.